is a lapsed Fortran developer with an interest in 1970s jazz fusion and computer research papers of the same era. So Graham, whenever you're ready, I'll let you crack on.
Okay, guys, let me just share my screen. Give me one sec. Right, okay. Hopefully you can see that now. All right, okay. Let me I'll just cut the video as well and go, okay, well, thanks for the introduction. My talk is Stacks, Bugs, and Rock and Roll. Okay, so this month marks the 50th anniversary of the third and largest Isle of Wight Festival. August 1970, the English holiday hotspot became the gravitational centre of the counterculture, with Hells Angels, hippies, and a few ill-tempered anarchists all congregating to soak up 5 days of peace-loving music. On the bill were the Doors, Sly Stone, The Who, Joni Mitchell, and here's Hendrix's bass player.
The crowd, it was overwhelming. It was monstrous. I've read the specs. They say 600,000 people were there.
So Jimmy, Billy, and drummer Mitch Mitchell cut up the psychedelic haze at 2 a.m. in the final morning. But driving the sounds that weekend, or for those 5 days, was the largest stack of power amplification ever assembled. Pioneered by South London engineer and accordion enthusiast Charlie Watkins, Charlie rejected the prevailing trend of using valve amplifiers, opting for the cleaner, leaner, solid state model. They were then stacked to create the largest power amplifiers
bit more volume on this one, Charlie. It's going to need it.
Ever assembled. Meanwhile, in the US, another Charlie was interested in stacks of a different sort. Charles or Chuck Moore was working on the IBM 1130. Same year, he released his paper, Forth a Language for Interactive Computing. So tired of bloated, hierarchical approaches to programming, Moore rejected the multi-level nightmare and proposed a simple stack-based model favouring bottom-up design and small, elegant programs. Here's Chuck Moore describing the complexity and the problems with current approaches. 10 times the code, 10 times the cost, 10 times the bugs. Here's a great quote from Charles Moore. So our kind of first encounter with stack-based programming may have come in the form of like scientific calculators and the reverse Polish notation, where operators follow their arguments, i.e. postfix expressions. Okay, let's dig into Forth a bit and this language for interactive stack-based programming. Here's how we define the stack. Every time you enter a command, it will return OK or error. .s is what you can use to interrogate the stack non-destructively. So you can see here we've got 3-element stack with the integers 1, 2, and 3 on there. Then we can start adding operator words. So you can see how those last two operators are combined to form the sum. Similarly for the product. And we can read elements off the stack using the dot notation. So here we apply that postfix reverse Polish notation and how that operates. So you kind of see that that model, and playing around with that, it gives you that kind of interactive feel, you're used to with using REPLs and stuff. Here's an interesting exception from a stack underflow if you try and read something that's not on the stack. Okay, so that's fine, but how do you define your own words and add things to the vocabulary? So luckily Forth allows you that ability using the colon word. So let's add a fuzz box and turn everything up to 11. Okay, that's pretty good. That's one for Led Zeppelin fans there. Okay, so far so good. We can kind of use this model. We can add items to the stack, read items non-destructively, check them, and we can add our own words to the vocabulary. So you can see how we can start building up things. There's also a lot of stack shuffling operators that are available out the box. So we can duplicate items on the stack. We can drop items off the stack, for example. And we can swap the last two items, etc. So you can see how we can start to build up a useful kind of computing model here. Also, we've got rotate, takes three items of the stacks and rotates first 1 and 3. So yeah, so things are coming together now. So we've got integers, we've got the stack. We can kind of operate on those, change the values at the top, and so on and so forth. This is great. Okay, so the next thing we need to do is look at how we can kind of get character representations here. So luckily there's a Forth supports an emit keyword where we can build up small strings, for example, and get the character representation of those codes. So for example, we can print out wow, far out indeed. And we can also create operators or values for carriage returns. So we can start to print out on separate lines, for example. So here's an example. We'll print 100, 200, and 300 using the carriage return word. Okay, this is getting better. We can also define strings. So using our colon operator as before. Now let's define a say hello string. So the dot quote, our string, then delimited with a closing quote.
Hello, how you doing, England? Glad to see you. We'll do a thing called freedom.
Okay, that's okay. Pretty useful. Right, so building up from that, what we need now is some way to, represent Boolean logic. So, let's, for example, say we want to, compare two integers. And interestingly, Forth uses -1 to denote true and any other value to denote false. So we can, okay, that's that's fine. Yeah, there we go. All right, so true and false, -1, 0. And we can also combine Boolean operators using and. Similarly for or. And not or invert as is known for. Okay, so. Okay, Boolean logic done, that's fine. The next thing we want to concern ourselves with is can we define conditionals, like if-then expressions. So here's the if construct in Forth. So is it 0? If a match is 0, else no. Okay, let's see what that looks like. Okay. So far so good. 1 is it 0? No, whoops. No. Okay, finally, we need some kind of looping construct. So this is how you would do this in Forth. Let's, a standard for loop in Forth. So from 0 to 9 here, okay, using let's see that in action. All right, pretty good. So far so good. So with that in place, we should be able to do something useful. And let's define the old classic 60s special fuzz wah, which was kind of taken off from later became fizz buzz. So here's how fuzz would look like in fourth. You can see how we check to see the top of the stack is divisible by 3, and then we use duplicate to duplicate the result, and the top copy of the value is consumed by it. Similarly, we can do wah for 5 if it's divisible by 5 to do a similar operation. So what happens is the second copy is left on the stack and acts as the return value. And if the number of the stack is divisible by 3 or 5, the string will be printed. Otherwise, there'll be no output. Okay. So this fuzz wah and fuzz and wah, and literally and combine. The next value is fuzz wah itself. All right, you can begin to see the pattern here. Okay, right, I'll invert that. Great stuff. Let's see how that sounds. So if we do fuzz wah, then we can concatenate those pieces together. Okay, whoops. Right, well, let's have to define that. That would help. Using our colon word. Let's see what fuzz wah. Sounds about right. Okay, excellent. So that's a little introduction to fourth. Here's Miles Davis. So what happens if we kind of fuse this stack-based approach with ideas from other programming models? So, for example, code as data and a kind of an interactive environment. Well, this is the kind of modern approach for Factor, which is a concatenative stack-based programming language with higher-level features and drawing inspiration from Lisp and Smalltalk. Here's the Factor listener. You can see it's a similar stack-based approach. You know, we have our clear commands, and we have the reverse Polish notation, etc. We've also got additional pieces, like such as quotations and lambdas and so on and so forth. So it draws on a lot of other research that's going on in programming, such as the Joy programming language. So let's have a look at what a similar program would look like in Factor. And we'll call this flute fuzz. So mult word determines if x is a multiple of n, first checking whether x is a number. It might be a string, x might be a string, you see. So then we chain it together with other components, and one of them deciding to return a string. Okay. So when mult returns a string, if x over string is a multiple of n, returning x over str otherwise. Okay, so with those pieces in place, we can build up the flute. You hear it as an action. Okay, so 1, 2 flute. Okay, fine. So far, so good. It should be sort of smooth right from here, similar to our approach that we did with fourth. So, okay, so here's a fuzz. Yeah, okay, what we've got in our stack. 5. Okay, we'd expect fuzz here. Yeah, that's pretty good. Okay. Yeah, fine. So you can see the pattern beginning to emerge. Okay, finally, flute fuzz. All right. So piping those all together and kind of concatenating them in a pipeline, we've got a nice little combination here, like a functional composition. All right, we'll define a sequence operator in there, and that will allow us to do a similar thing with within a range, a sequence from 1 to n. Okay, so I'll call it, we'll just end that pipeline there. That's kind of the beauty of Factor, really, neatly lined up. Okay, let's run it. Let's run Fruit Fuzz. That's it.
Brilliant. Thanks.
Sorry, a bit over.
Really appreciate that. Well, I just hope other people are able to keep up with the programming better than me. As a non-techie, much of that went straight over my head. But amazing to see it done actually, live and see it going through. Has anyone got any questions for Graham on the presentation before we move over to Anirban? No, I think you got away with that one. Okay, I've just put a link up in the chat. So a big part of these events, as I mentioned earlier, is to practice. And obviously getting feedback when you're speaking is really, really useful. So if anyone has any words of feedback, there's a few multiple choice things that you can use on that. So 30 seconds, 60 seconds, just have a look through that. Really appreciate some feedback for both Graham and Anirban after his presentation. So Anirban, are you ready? Are you sharing screen? Are you talking straight?
Yes. So first of all, I'm audible, right?
Yes. Yeah. Can hear you fine.
Okay.
So
please share my screen.
Okay. So just in case you don't know Anirban, he's an application architect at IBM Global Business Service UK, currently working on a digital transformation of core banking applications. He's got in-depth expertise in all the cutting edge technologies, Microsoft Tech, DevOps, AWS, Docker, Kubernetes, Jenkins, ELK, and has been passionate about digital transformation. So Anirban, whenever you're ready.
Yes. Yeah. So today's agenda actually, what I am going to discuss today, in my last project actually, is a banking project. I used to do the production support so there were lots of repetitive tasks. We used to analyze the logs generated in Elasticsearch and just do the production support after analyzing those data and was trying to find out the different problem areas. And at the day end, we used to send email with all those details to the intended recipient. So in this, and that time when I was doing it, I feel like why some of the tasks I could not share with machine. And in that regards, actually, I have implemented some automation of the process. And in automation, I feel like some of the straightforward rules or recipe do not fit with the complete automation. And then I come to the machine learning areas, learn it and applied it. So that's actually the journey, my complete journey, what I did. And I just want to explain it. And I believe it would be useful for the developers who are also doing the support of the repetitive task and try to implement it as an automated task. So, and some areas actually we developer have confusions like what is the use case for the machine learning. So that also I'll cover, but everything in terms of the problem I have faced and how I have overcome that. So just before discussion, okay, 1 minute, yeah. So I want to explain our existing system. It's a very simplistic view of the existing system, where in AWS there are multiple microservices, and one of them is pretty important, which is the account microservice, and those microservices talk each other and also access or communicate with the core banking services, which is actually core part of any banking industry, the core banking services through channel. So very high level overview of how the calls get connected. So it's through the AWS proxy. It's a proxy for the security implementation. Now the request passes through the F5 load balancer. There are third-party proxy services as well, and after that there are different kind of, again, gateways, for example data power, and ultimately request reaches to the core banking service. So how the logs generated, since in a distributed environment, ELK, Elasticsearch, Logstash and Kibana is the one of the very important component to store logs. So all the logs are being generated in the services are stored here, as well as from the AWS proxy, which particular request is being forwarded, that is also stored over there. So what we used to do, initially we used to do a manual report generation every day at the day end, and get the data, compile the report and send it over to the email to the all recipient who are actually intended for it. But that was a kind of manual task. First we wanted to make it automatic. So to do that, whatever we did, first we used the Elasticsearch watcher, and the Elasticsearch watcher is a functionality in Elasticsearch. You can use it and you can customize the log you are getting from the ELK and generates various reports and also trigger email. And that was the initial solution, the first stage of automation. But there were some problem associated with it. So here I given bit of explanation of the watcher, how watcher looks like. But the problem is that the watcher does not support the popular scripting languages. You have to use either Groovy or Painless, and Painless, by frankly speaking, it's very painful. So you have to implement in a Java way of writing code that kind, but there is no good editor embedded with the Elasticsearch where you can write the code and you can run it or you can debug it. So it is not possible at all. Secondly, so the data we are getting in Elasticsearch is bit vast actually. We have to do some processing. So the process data we need to store again in another index, and this is not very useful because it's not flexible enough. And the Elasticsearch only store data in terms of JSON, so which is problematic to store maybe any complex model or something like that. So and the machine learning also Elasticsearch provided that time and now also, but the machine learning is pretty embedded with the Kibana visualization. Only you can see from the Kibana visualization. You cannot work like your application cannot use that particular model. You can leverage it with the other parts of the application. So we felt that okay, that's only using Elasticsearch might not be a right solution. So the next step whatever we took is created the batch job. So those are the Kubernetes cron job we have created, which in a nightly every night it runs, and it just executed the query on top of Elasticsearch, process the data and store it into the MongoDB in our system, and generate and we also created another job which is a report generator. We replaced the watcher with the report generator. The report generator works on top of those records and send email, and we can schedule it. So that's particular things we have implemented. So the benefits of using this logic is that it was a data processor. So the Elasticsearch logs, actually this processor reads the data, flexibility in handling the log in MongoDB, and obviously the logs are more durable. So that is the next approach we have taken. Next, I am just giving you an example where we faced some problem. Suddenly, one day we have realized that the email generation failed of a particular account opening. What happened actually system is that, so in an account opening, actually for a particular application, those actions are performed in serial, sequentially. Like at first the ID check of the applicant is being performed, and after that the customer is getting created, and finally account opened. And as per the business requirement, we waited for one day and then the comms will be sent over to the customer. But we found that the com was not sent some of the records, and we have analyzed data by manually visualizing the records and the logs and everything, and identified that in those cases where the same action, because whenever the ID check action has already been performed, it should not be triggered again. But some other port, I have saying here, this is the port name, the processor, some other port has picked up that particular state of the record and process later, after a delay, process later. So I am not explaining what was the root cause of it, but we found out a deterministic recipe that whenever the particular action is greater than one with a two different ports. So for example, here ID check has trying to be performed 2 times, then it would be a problem. And everywhere we have applied that rule, we found that the problem deterministically. So that means it's an instruction. Machine has not learned anything yet. We have analyzed it directly, visualizing the data, and we are instructing the machine to work on that. So I would say this is a kind of machine learning, because some of the books and some of the places it is said that where we had a ready-made recipe, it is not the use case of machine learning, but it does. Because for example, if I say to my 4 years old toddler that don't touch the fire, it will burn your hands. So it's an instruction I am giving to him, and he's learning. So it is not the case that always he needs to touch the fire and check how it looks like. So that not happening always. So machine learning, that's actually we have also applied is, if we have a ready-made recipe as well, we can put it into the model, and machine can deterministically, that means definitely, give the result. So what we do next, we have just added a model database into our MongoDB model collection. We feed the recipe manually every day. That means it's a learning. That means whenever as a human I have been learning to do something, why we could not teach machine to learn the same thing, so that it will share my work. So I just feed the recipe to the model, and that's fine. Then whenever the next step, when the web app trying to generate the account and the services got that kind of same sequence, like another port just pull the request, then and then it will alert. And generally the email sending has been done one day later, so we can get the information prior to spending one day, and we can take corrective action. So that is actually the stage 3 we did by applying recipe. Now I'm just trying to explain another issue which was very hard. We found that some of the account openings are failed. I really don't know what was the problem, and it was surprisingly intermittent issue. So one customer is trying to do that, the account opening got failed, and second time when he was again trying to do that, it was successful. So it's completely intermittent issue. By analyzing the data, we were not able to identify what was the problem, and it was very hard to detect. It seemed like a environment issue, because sometimes it is working, sometimes it does not, and it's a very big problem. Check that the call is, that means the request is flowing through all the way from the AWS to core banking services. Frankly speaking, we don't get the end-to-end log. So how to check that one? So it's a root cause we really don't know, unknown. Let's analyze the data. So what we have detected, we have somehow identified that problem might be with the environment, might be load balancer, because sometimes it is working, sometimes it did not. So I am just giving you a quick data. It's a very, very simplistic view of the data. It's a huge log because it was like including all the logs are generated with different stages of the application. Huge log. I have taken a bit of it. Check that the log Nginx is forwarding those requests to the core banking solution, and we can first check that the HTTP 500 returned for some of the IPs like 100, 1114 this IP, but we cannot say that it's a problem because for that IP we get 500, but after 2 retries we get 200. So this is not a problem. We cannot say that it is a 500 HTTP means something happened. We don't know that. Second point is that very important point. Some of the request response time is too high. Check that upstream response time is too high compared to the other response time. It's like 327.004 milliseconds. So it's kind of a huge time. And finally, we have realized the red color one. Check that those areas, those things, those IPs are generally being failed. So we really we cannot label the data because it's a huge log of data. We can run unsupervised learning and we thought of like we can make a cluster. K-means cluster algorithm we can apply to find out the cluster wise that where the problem is happening. We applied the cluster K-means cluster, but we did not find out anything. And then when just analyzing the data, we found like, yes, there's a huge number of logs, some of the records are anomalous. So why could not we run the anomaly detection algorithm? And anomaly detection algorithm we executed and found out that, yes, some of the IPs where it is not like 147, the IP ended with 147 was not working. And for that, the anomalous record was the upstream response time was very, very anomalous. It is very high. So what we did, then we identified that now we could apply the machine learning. We have introduced another trainer processor and trainer processor runs every night, work on the records which is being received from the ELK and update a model with its findings. And we are trying to find out that what is the accuracy. Till the accuracy is not 50%, we are not able to apply it to our application. So we started, we have introduced that trainer, and the trainer does those kind of things like it trains the data, trains the model. So this is the 4th step we have used. Now the point and draw from the intermittent issue is that issue was intermittent. Yes, it seemed like an environment issue. Number of log were huge. Proper labeling of the environmental log were difficult. Anomaly detection was the best fit. So why I'm explaining that if developer just faces that kind of situation, then definitely they can think of it where the labeling is not possible. So we can run an anomaly detection and check that which particular areas it is failing. Next, the case 3. This is actually a different problem we have faced. So ID check failed. So some customers, the ID check is getting failed. Why it is failed? So that's also we really don't know. And we after analyzing the data, we have found out that the multiple requests are coming from the same user and look like a fraud. So what to do? Next, we need to know what kind of fraud it is. And early detection is needed. Because why the early detection is needed? Because that ID checks involved cost. So if we detect that it might be a fraudulent user, then we can take corrective action before passing his record to the ID check service. So the root cause is still unknown. There is no ready-made recipe, and nature of the fraud changes over time, because the thing is that today if we find out maybe some set of areas where the request is coming in giving this kind of problem, in future it might not be the case. So same what happened actually, we have identified that user actually requested for the application account open 2 ways. They are not using browser at all. they are just directly, they are just calling the services. I really don't know how, but there are lots of, we have identified the reason for that, but this is not the purpose of the discussion. Somehow they are just trying to access the application directly calling the service, and ID check is getting failed. So if we check that, then we just started analyzing the data and find out that some of the requests, there is no browser user agent at all. We were capturing that. That means the requests are not coming through a standard browser. And mainly the applications, so those are all the problematic records. So the addresses are checked that it is repetitive application, so retries multiple time, and those are all the IP addresses from where the requests are coming in. So based on that, what we did, so the range, and it is triggered manually, and yeah, it's coming from the IP address. So the next step what we followed, we tried to identify the geolocation from where the requests are coming in. So after analyzing that, we find out that the geolocations, I have here only shown a two set of data. Its data is huge. So we have identified the geolocation 1, 2, 3, 4. It's associated with the countries and the region. And here the updated browser, we just transform the data that they are using updated browser or not, in case of retry or not. And we are finding out where this 1, 2, 3, 4, this 4 region, the requests are coming in with a multiple retries, the success is very low, it's 0, and otherwise it is successful. So it's looked like a classification problem. So model is developed with a logistic algorithm, regression algorithm. Okay, the application check whether the request originated from the suspected geolocation or not, and system can early detect it and show a error message. So, and from that also we have identified and we have corrected, we have taken even preventive action that if the user browser agent from where the request is coming is not standard, that means not following a standard regex validation, then we can block the request. So those requests have been blocked. Okay, and the model is being retrained every day to make to get the proper good accuracy. So that's okay. So I'm just now quickly show the demo. That means it's a video lecture. Just keep on saying, and okay, that's so what take that this is the data actually got. So I'm not using the Elasticsearch here. We have just for the demo purpose we are using it. Check that for the 8 the geolocation we are getting a success response. So now this application, what is being done, it's developed in a .NET. I'm just going to a debugging mode. So how to develop it in .NET? I have implemented using the ML.NET. It's pretty easy. We can develop in Java as well. So we have created the pipeline, and the pipeline we have provided the feature geolocation and update browser, and using a logistic regression. Now created a model and save it. So when the model has been saved, then I just want to test it using the training data. So using the test data, we train it using the training data. Now that using test data, we have tested it. So when the prediction has been done, now you will get the result. So when it is done, we found that 75% accurate the testing is. That means we are in a pretty good shape, and we discussed with our product owner that if it is more than 60% accuracy, we can go for it. So now let's take that we have implemented the logic of getting a data like 810. 8 is the geolocation, 1 is retries 1, and 0 is he is not using the browser, correct browser. And now if we application is run, so it will give a success. That means not a fraud, because the request is coming from a geolocation. Yeah, it's saying like fraud is negative and probability is 0.999251. So that kind of implementation we have developed, and that model has been fed to our architecture, our setup, so that our application use that model and just predict correctly. So next I'll just come to a summary of that, because lots of developer have dilemma that why we use the machine learning, why it is very useful. We can use the recipe only. So that's fine, but we can follow the stepwise approach, and then we'll come to the machine learning if it is required. So at first I would say that who are their initial phase to do the machine learning. So one very best fantastic course available, everyone knows about it. So Andrew Ng Coursera course, just complete it. Then identify the problem first and think on, can machine learning help on this? So that is the first thing we have to think, because we need to identify some situation where we want to share some of the repetitive work with the machine. Next, develop the automation framework as I have explained, and start with the ready-made recipe. This is the first phase. We will develop an automated framework, and we'll start with the recipe. Okay, we are not applying any machine learning algorithm, but we'll start with ready-made recipe, because a ready-made recipe will give you 100% confidence level. So at least we arrived middle of the road that, okay, we have automated something. Then identify the use cases where the root cause cannot be logically derived by the browsing or simply observing the data. So the problem is that where we can observe and we can find out the recipe, we can fit into it. And secondly, just create a CSV file out of it, run the ML algorithm, machine learning algorithm. Now the fit that particular model to the automation framework, and very importantly, update the training set on a regular interval, and just update the model continuously and check the result. So that's all the steps we can follow, and we can automate and share some of our repetitive work with machine. So that's all from my end. And yeah, so some references I have given, the Coursera course reference also I have given. So that's it. Thank you.
Brilliant. Thank you very much, Anirban. Do we have any questions out there from anyone? Saman, what machine learning algorithms would be good for anomaly detection?
Yeah, in .NET there is a algorithm, machine learning anomaly detection algorithm is available. So if you just go to the details, so there are different segregation of the machine learning in one anomaly detection. I just don't recall the name. I have given the URL. You just go over there, the machine learning resources task, you will find out the different type of algorithm. So if I just open it, for example, I'm just a bit conscious about the time, but yeah. So yeah, so here they have different kind of binary classification. So multi-class, and ultimately you will get clustering and anomaly detection. So anomaly detection, we have randomized PCA trainer. So that's particular things you could use. Yeah.
Great. And I think we had a question from George as well. What machine learning tools are you using?
I am using ML.NET from .NET framework.
Okay, great. All right, fantastic. Well, thank you, Graham. Thank you, Anirban. Appreciate that, and thank you to everyone who tuned in. One more attempt to push this lightning talk. We could do with 2 more speakers. I'm just trying to find the link that I know you all want to go to sign up to, so that you can sign up to give a talk, and I'll post that here in just a sec. There we go. So if you're open to talk on Friday, then please do. Even if you just want to come along and see the latest batch, then you're more than welcome. But yeah, and there's two links. There's another link there for feedback. So if you don't mind, then just open that, and if you've got a chance, you can tick some of the buzzwords at the top there. Sorry, I think I put the wrong link on initially, but that one should now work. Oh no, it's still not working. Oh, well, if the first link there is for feedback. So if you've got anything that you can add or show any appreciation to Graham and Anirban, then please do. And otherwise, we'll hopefully see you guys on Friday. So I hope you've all had a nice lunch. Cheers, guys.
Yeah, thank you.